Sentiment analysis in natural language processing. AI intermediate level. Introduction. Human language often expresses opinions, emotions, and attitudes. Understanding whether a piece of text is positive, negative, or neutral is a key task in natural language processing. This task is known as sentiment analysis. Sentiment analysis helps machines understand how people feel about a topic, product, or service. It is widely used in social media analysis, product reviews, customer feedback, brand monitoring. Sentiment analysis is one of the most important real-world applications of NLP. What is sentiment analysis? Sentiment analysis is the process of identifying and classifying the emotional tone of text. In simple terms, sentiment analysis equals detecting whether text expresses positive, negative, or neutral sentiment. Example concept. Text means sentiment means label. Example: I love this product means positive. This is terrible means negative. It is okay means neutral. Why sentiment analysis is important? Sentiment analysis is important because it helps organizations understand public opinion. Benefits include analyzing customer feedback, improving products and services, tracking brand reputation, making data-driven decisions, monitoring social trends. Example concept. Customer feedback means sentiment means insights. Types of sentiment analysis. Sentiment analysis can be categorized into different types. 1. Polarity-based sentiment analysis classifies text into positive, negative, neutral. Example: great service means positive, bad experience means negative. 2. Fine-grained sentiment analysis provides more detailed sentiment levels. Example: very positive, positive, neutral, negative, very negative. 3. Aspect-based sentiment analysis analyzes sentiment about specific aspects of a product or service. Example: the phone camera is amazing, but battery life is poor. Camera means positive, battery means negative. 4. Emotion detection identifies specific emotions instead of just polarity. Example emotions: happiness, anger, sadness, fear. How sentiment analysis works. The typical workflow of sentiment analysis is text input, down-pointing arrow, text pre-processing, down-pointing arrow, feature extraction, embeddings, down-pointing arrow, model prediction, down-pointing arrow, sentiment output, text pre-processing. Before analysis, text is cleaned and prepared. Steps include lowercasing, removing punctuation, removing stop words, tokenization. Example: I love this product means love product. Feature representation. Text must be converted into numerical form. Common methods: bag of words, TF-IDF, word embeddings, word2vec, glove, fast text. Example concept: text means vector representation. Machine learning approaches. Traditional models include logistic regression, naive Bayes, support vector machines. Example concept: features means classifier means sentiment. Deep learning approaches. Modern methods use deep learning. Models include RNN, LSTM, CNN for text, transformers, BERT, GPT. Example concept: text means deep model means sentiment prediction. These models capture context and improve accuracy. Rule-based sentiment analysis. Simple systems use predefined rules and dictionaries. Example: good means +1, bad means -1. Limitations: cannot handle complex language, fails with sarcasm. Challenges in sentiment analysis. Sentiment analysis is not always easy. Challenges include 1. Sarcasm. Example: great, my phone just broke. Amazing. Quote 2. Context understanding. Same word may have different meanings. 3. Negation handling. Example, not bad means positive. 4. Domain-specific language. Words may have different meanings in different industries. 5. Mixed sentiment. Example, the product is good but expensive. Example Python code. Simple sentiment analysis using text blob. From text blob import text blob. Text equals I love this product. Quote, analysis equals text blob. Text, print, analysis, sentiment. This outputs sentiment polarity and subjectivity. Real-world applications of sentiment analysis. Sentiment analysis is widely used in many industries. Social media monitoring. Tracking public opinion on platforms like Twitter. Product reviews. Analyzing customer feedback on e-commerce platforms. Brand reputation management. Understanding how customers perceive a brand. Customer support. Identifying frustrated or satisfied customers. Financial analysis. Analyzing news sentiment for stock prediction. Advantages of sentiment analysis. Advantages include quick analysis of large text data, automated opinion mining, improved decision making, real-time insights, scalable across platforms. Example concept, large text data means sentiment insights. Limitations of sentiment analysis. Limitations include difficulty understanding sarcasm, language and cultural differences, dependency on training data quality, limited context understanding in simple models. Sentiment analysis versus emotion detection. Sentiment analysis. Positive, negative, neutral. Emotion detection. Happiness, anger, sadness, fear. Future of sentiment analysis. Future trends include better context understanding, multimodal sentiment analysis, text plus voice plus images, real-time sentiment tracking, improved accuracy using transformers. Example concept, advanced AI means deeper emotion understanding. Concepts learned from sentiment analysis. Understanding sentiment analysis helps learners understand. Checkmark how machines interpret human emotions. Checkmark how NLP processes opinion-based text. Checkmark how classification models work. Checkmark how AI is used in business decision-making. Checkmark how language context affects meaning. Simple definition. Sentiment analysis. The process of identifying and classifying the emotional tone of text as positive, negative, or neutral. Final summary. Sentiment analysis is a key application of natural language processing that helps machines understand human emotions in text. It is widely used in social media monitoring, product reviews, and customer feedback analysis. By converting text into numerical representations and applying machine learning or deep learning models, sentiment analysis enables systems to extract meaningful insights from large amounts of text data. Despite challenges such as sarcasm and context, modern AI models continue to improve sentiment understanding.